Hey, welcome to Community Day Midwest. I'm Nathan. I'm from the Indianapolis user group community. I work with U-Turn Data Solutions based out of Chicago. I'm the head of solutions architecture. Some of my friends and compadres are in the back. So anybody here used Rekognition or, yeah, I know our team has, which is why I'm talking about it. Back there, a little bit like object detection label stuff or facial or, well, let me know. So what I'm talking about, some of our firsthand experience working with Rekognition, and Brooke kind of really teed me up this morning. So what I always like to do is start with an I spy with my little eye, a cup in the back. And that's kind of my analogy for what Rekognition is often used for, is recognizing objects or things, faces, people, paths, etc., in video and imagery. And it worked really awesome. I'll talk about some of the lessons learned. I need to set my timer here because I'm on a very short leash. But, there's some specific challenges around using Rekognition, particularly around security, scalability. And when I say security, not just like information security, but in terms of like what you're doing with people, in terms of legislation, laws, privacy, etc., and cost efficiency, which I think cost efficiency is particularly difficult with Rekognition. Yep, I got some head nods. My man knows. All right, so yeah, I had a solutions architecture with U-Turn Data Solutions. I also teach cloud at Ball State in Muncie, Indiana, and lead the Indianapolis Community Group. Help run this show. So really, what's computer vision? I think it's kind of obvious, but I always like to just explain it really simply. It's things you see, that a camera might see, images, video, movement, even thermal imagery, et cetera, fits into that. So Rekognition can do quite a bit of that. And when you think of computer vision, I think of Rekognition, the AWS service primarily. What is Rekognition? Again, this is kind of a 100 level, so I apologize if you already know all this stuff, but it's got a whole bunch of different features. Features like Face ID, which I think is, kind of what I'll talk a lot about coming up here, but it's image analysis. And that's what, like Brooke was showing, the squirrel with the leaves and the squirrel and those different object detection labeling. So a lot of those kind of APIs, and you can train it to find your own things. So, right, if you've got a warehouse and you need to check to make sure that there's a safety vest or at least 5 safety vests in the room, maybe you're going to use Rekognition to count those objects. Or did somebody walk through with the proper PPE? There's video analysis, works really well. There's kind of different approaches. Object detection, I think I touched on, fire extinguishers, text detection, and reading. So if you're going to read like somebody's name on a uniform as they're walking through, like a badging in, badging out area, or a contractor entrance. PPE detection, or license plate reading. So it's kind of big brother stuff. And then PPE detection, which has anybody used the PPE detection stuff? Okay. All right. Well, we'll talk about some of it. All right. So what are some of the main considerations? So let's say you're setting up a new platform and you've got, a computer vision type solution. What are the big concerns? One is cameras. Usually we're used to setting up something in the cloud and we can control everything and deploy it as code. Well, you can't deploy a camera into an environment with code. At least I haven't figured that one out. That takes some lead time, especially if you're in a highly regulated, secure environment. Getting that camera set up adds a lot of front end time before you can even start on your project. So planning out positioning, et cetera. Support on that camera system may be really bad. Some of these camera system vendors, these platforms are like 20 years old. Total pain in the what to work with. You may have to install streaming producers within your environment to actually push that stream out if you're going to use that RTSP feed. And then there's privacy, right? You may have a union contract, in your environment, employee agreements, state, local laws, there's all sorts of stuff. Like, can you actually collect the data that you might be able to get from the camera? Cost at scale. I think you raised your hand. It's what I found is it can be very expensive if it's always on, especially. And device management. If you've got 100 cameras, how do you manage the fleet of devices? You're in IoT world now, right? So maybe you've got IoT core, something like that. And then inevitably, because you have a camera on site, if you're using the actual camera to collect the system, you're going to have some sort of hybrid architecture. And so that introduces all the security and integration challenges that go with that. And I think I already mentioned camera support, but I found that it's very difficult to find camera vendors who know really how to integrate well into the cloud. So I'd be interested if you have found some good ones to work with, because it was very difficult. Security, think of hybrid architectures. Here's what I think of when I'm trying to, how do we lock down security on this? Hybrid architectures, privacy laws, bastion hosts. If you've got a server out there collecting a video stream, how do you secure that properly according to your customer standards? Especially if you're, have a highly regulated environment, DoD, et cetera, you better make sure that that is locked down and very secure. Data isolation. How do you isolate that data, especially if you're like doing something in Europe with GDPR, et cetera? You're collecting personal data on people. How do you make sure that that's isolated from somebody else and you're tracking all that? Device fleet security, right? How do you deploy a camera, connect it to your environment, and do it securely without somebody hacking that camera, getting that stream, et cetera? It's a whole different level with that hybrid architecture. It's almost an IoT discussion. And then camera deployment. How do you deploy the cameras? Where do you set them up? What angles are they? What are they looking for? What's their resolution? What do they provide? And again, the scalability, like how fast can you grow your platform? Camera deployment. It seems to be, it's the physical deployment of cameras into an environment. It seems to be a very limiting factor in how fast you can scale it. Tenant isolation and data privacy, thinking about how to set up and secure a particular tenant or a cell-based architecture for a camera or a group of cameras. And maybe they have different things that they're doing, so they need to secure differently. Setting up those streaming producers. If you're doing a live feed, how do you set that up and deploy it securely? Because you need basically one streaming producer for every camera. So now all of a sudden you've got all these different assets deployed out in your on-prem environment. How do you scale your IoT device fleet? And then making sure you've got a scalable, secure landing zone. So AWS has landing zone accelerators. I know we do too as well, that we set up and deploy. It helps tremendously if you've got a blueprint for how you're setting up accounts and securing your landing zones. Costs. So this is where it gets expensive, because Rekognition is fantastic, works really well, but it's very expensive. And so some of the things that you can't do, you can't go buy a reserved instance or a compute plan with Rekognition. Ask that question 100 different ways. How you decide to process that media. Are you going to do stored video processing? Are you going to just look at images? Are you going to have a camera sending you a live feed and you're going to process that with a Kinesis stream? That all affects, those are very different pricing models and can get very expensive quickly. How you manage that fleet, right? If you don't have an IoT or, a large scale fleet management platform in place, like IoT Core, et cetera, how are you going to manage 100 devices in your environment? That can be expensive, not necessarily in terms of the cost, but in terms of people hours. What are your data retention policies? These things create a ton of data. I think we had a situation where we deployed one camera and we got like 20,000 images in a few hours and we processed all of them. And you're like, do we need to keep all those? How long? And so all of a sudden you're trying to figure out how you manage that spend. Accuracy requirements. If you see something, how accurate are you? Are you 99.9? Are you 80%? What's acceptable? And so, how much you turn up and turn down all those images you're processing. Like if you see it once and it's 80% accurate, is that good enough? Or do you need to see it 5 times 90% accuracy? And then you're good enough. It can get really expensive fast for that last, 5 nines kind of mentality. Objects, people, and model training, how much you do there, how many objects, that drives cost. So obviously if you're taking one picture and you're going to look for 50 things in it, that's a lot more expensive than looking for 2 things. So kind of 3 main architectural approaches that we've used for video and image processing is the live RTSP feed. That's pretty nice because most cameras support that. And so you can capture that, but it's a little trickier, a little expensive. Stored video, which works really well, but it's very expensive. It's like 10 cents a minute to process that. So it gets expensive fast. Not the storage necessarily on S3, but the processing of it. And then images only, which seems to be the most cost efficient, just depends how many images you're processing. So with RTSP, I've kind of mentioned this. You start with the camera, you got to set up with a video producer, you send that stream into Kinesis video stream, and then you process it with Rekognition. You get pictures out of it, store them in S3. You use Lambda and step functions to look for the different objects maybe you're trying to detect. And then, you're going to query that with Athena, or you're going to have some sort of reporting platform like Quicksight to look at data out of that. And then, of course, you're going to be looking at event data. You can do all sorts of streaming and training on your own AI. If you're doing like a risk profile, say somebody's walking into an area, you don't recognize them, you're starting to track an unrecognized phase. They don't have PPE equipment on. Oh, that's a high risk. You're building risk scores. So lots of back-end processing you can do with the data. And then with images only, oops, I'm scrolling past. Images only is great if you have a camera system that can give you the images you want and you don't have to actually go create them out of Rekognition processing. So for some reason you've got an image. Let's say you go to the camera system, you say, give me every image that take an image once a second and send that in. That might be good enough for your use case. That's a really much more cost-effective way to go. But you're offloading some of that to this camera system, which is really going to be dependent on what they can do. And it's not always reliable. We found if you can throw it up to Rekognition, it'll handle everything and does pretty well with it. If you have to rely on the camera system, it may not be up to like AWS standards. So a lot of times we do notifications, Athena queries, etc. Stored video and MP4s. That's really great because you can use all sorts of data stores and you can go back through all sorts of historical video, process it, but it's very expensive to process that. I don't know if you've done the stored video processing, but it can add up fast. One way to do that is you could, of course, take you could just have your camera system store all the video. You just pull that in and you don't even have to mess with the camera feed or extracting images. You just process it straight out of the stored video and works great, but it's very expensive. All right, keep rolling. So here's some of I think I'm doing okay on time. I'm flying through this, so my apologies. Here's some of the things I think worked really well, at least from what I've seen. It works fantastically for face detection. Works really well. We're able to take, load in a library of profile pictures. And even if it's just a full-on front face picture, we don't have to train it with faces from different angles of the same person. Works really well. And we're getting like 98% accuracy on doing that. It's really good. So when we trained it, it worked really well. It also does a really good job, and this was very valuable for our use cases of people who aren't in the expected people in the list. And so that was actually much more valuable in some circumstances than finding just the people who should be there. It was nice for the security folks to go, that person is not in our list of people who should be in this area. And then it could track them as where they went elsewhere. So again, it's kind of Big Brother, but it was very helpful because now one security person can zero in on problem areas without having to watch, cameras full time. So stored video processes, it works very quickly and it's really good if you need to go back in and see what's the history of people coming in and out of this area in this particular person. It can work really well for that. It creates a ton of useful data for building risk profiles, events, ingress, egress, object detection, safety equipment detection, all sorts of things like that. And that's a double-edged sword because you have a ton of data. Maybe you have too much and you don't need to do that much processing and you have to balance cost with accuracy. So there's no silver bullet to that. It's really what's your budget tolerance and how accurate does this need to be? Because inevitably, you may use the computer to detect, AI is going to assist you in detecting problem situations, but at the end of the day, it's going to be somebody looking at that situation and investigating it. And then a wide variety of cameras can be used. So this is really nice. At the end of the day, you need an MP4. You need an RTSP feed, works really well if you can offload most of that AI processing to AWS and the Rekognition services. Some of the things to be aware of. Architectural approaches drive very different setup, scalability, operating costs. Hybrid architectures, a camera is going to be on premise. That's a whole different, when you have to physically install something in a building somewhere, that becomes a very different project for most IT folks. It's kind of like going back to a data center. You might require bastion hosts, which are going to always raise a security issue with the security IT folks. Camera positioning matters. You don't think about it, and then getting it moved right might take a few weeks. So you can't just, quickly change like we're used to. And then always thinking of what's the end result? How can I achieve this in a better way with using different API calls? Because the cost is is something significant to consider. And one thing in this middle point here, this is my ask to AWS. Like when you use a Rekognition, it's like all on or all off on the video processing. So I wish I could tell them to like dial it down or dial it low or high, but you can't. And so if you're going to use it, it's going to be all on, and it does a really good job, but the expense might be prohibitive. And then there's the use case, right? I call it the Fort Knox, right? If you've got a camera outside of a gold vault and somebody's only coming in twice a day, that's a pretty inexpensive thing to run. But if you're monitoring like the New York subway, sorry. Yeah, I know I had 10 minutes, Margaret. So the New York subway, and there's 1,000 people coming through, that's a whole different world. So, yeah. And then you can't use savings plans, discounts, et cetera. You probably have to do PPA negotiation. So I got to wrap up because we're on to the next thing, but here's my grid, and I'll leave with this. This is the grid of kind of, the 3 different video or image processing approaches that I take, and kind of how I rank them with cost, complexity, camera compatibility, scalability, reliability, support, tech debt. You can get that after this community day, and you can go get that grid. That's just kind of my experience. And so based on your use case, if you got all the money in the world, there's a lot of options available. So, all right, Margaret's cut me off. Thank you. Yep.